This conference will now be recorded.
Okay. Hi friends, in this Business Intelligence Master Program, this is our second session. So in this session, we will see introduction to Azure Data Factory. Okay. So in this session, basically, I will explain you one scenario where exactly your Azure Data Factory will fit. Okay. So once I explain the scenario, then I will introduce you what is Azure Data Factory. Then we will see code free ETL as a service. So what all main components we have in Azure Data Factory to do the ETL processing, because Azure Data Factory is an ETL service. So by using Azure Data Factory, what all components will support to do the ETL. So that particular things we will discuss. Next, we will see why this Azure Data Factory. So what are the unique features we have in Azure Data Factory? We are going to see. Then finally, Azure Data Factory V2 data flow architecture. So how the data is flowing in this Azure Data Factory, we are going to discuss. Okay. Okay. So now, so you can say Azure Data Factory V2 data flow architecture. So now we'll see the scenario. The scenario you can see, friends, assume a gaming company that collects petabytes of game logs that are produced by games in the cloud. Example, there is a game in the cloud. So everybody is registered for that game and you are playing the game. So when you are playing the game, what happens in back end? So they are going to collect all the logs. Okay, how much time you are taking to complete this particular game, how much time you are taking to complete each level. Okay, so how you are performing, even though you have performed in a mentioned timing, but if you are able to finish it in a very less time, so they are going to analyze, okay, this guy is the best. So if you look at any gaming site, so they will give you some kind of a points. How they are going to give these points based on the logs which they have analyzed it from the back end. So you are going to play a game from front end, all the logs will be collected in the back end. So these logs is going to be there in a petabyte size, because not one or two people on it. There are multiple people are going to play the game. So you are going to receive the petabytes of data every minute, or you can say every day. Okay, so huge amount of data you will collect in the logs. Now, what I wanted to do with this log? Okay, I understood. I played the game. I collected the logs. What I wanted to do with these logs? What is the advantage of collecting these logs? The advantage of collecting these logs is, see, the company wants to analyze these logs to gain insights into customer preferences. Example, with these logs, people are like gaming companies going to understand what customers is expecting, what are the customer interest, what are the customer preferences. So they are going to understand from these logs. Next, they are also going to understand number of people who are playing game daily, how many people are playing this game daily. Then they are going to see usage behavior. So some people, what happens, they will simply open it and they will close it. So you need to understand whether these people really played the game, at least they completed one level, at least that usage behavior also we need to understand. So now we understood, whenever somebody played a game from front end, we are collecting these logs and we are analyzing these logs to get the customer preferences, to understand the customer preferences. It's nothing but a customer interest, and to understand the number of people who are playing this game daily and usage behavior. So along with that, you also looking for, it also wants to identify upsell and cross sell opportunities. What is upsell? Upsell means whenever new customer, you need to attract the new users. How you will attract new users? You need to provide some kind of a discounts, and you have to offer them this particular game for less price, so that people will subscribe this particular game and they will pay, meaning they will play this particular game. So that's how upsell. Upsell means you need to attract the new users. Cross sell opportunities means within the existing customer, you have an existing customer who is playing the game. To these people, you need to offer the new features. You have to allow them to buy the new features which you are introducing in the game. Okay, next, develop new feature, drive business growth. So when you develop new feature, this feature at least some people will purchase. So when some people purchase this new feature, it will ultimately leads to business growth, right? So you can grow in your business. Then provides a better experience to its customers. So you are also going to understand, okay, so what my customers is looking for. So what are the new features they are looking for? You are going to provide the new features which customers are expecting, so that users are happy. So users will experience a like better experience. They will get it from this particular game. Okay, next. So now we understood that these are the advantages we are going to get if we analyze these logs. But so we understood, right? We have a game, you are playing game from front end, we are collecting logs in the back end. So with these logs, we are getting all these advantages. You are understanding customer preferences, you are understanding number of people who are playing game daily and the usage behavior. You are trying to do a upsell and cross sell opportunities. Okay, so it will lead to your business growth. We understood these things. With the help of logs, you can achieve these many things. But how to analyze these logs? Okay, how to analyze these logs? So to analyze these logs, the company needs to use reference data such as customer information, game information, market campaign information, that is in an on-premise data store. Meaning, so there are two stores, right? Cloud and on-premise. You see, this game is played in a cloud. You can see, assume a gaming company that collects petabytes of game logs that are produced by games in the cloud. In the cloud, games are people are playing games in the cloud. So all the logs available in the cloud now. Okay. Now, what is cloud and what is on-premise? Remember, cloud is nothing but your, let's say, you whatever laptop you have in front of you, that is there with you now. That is nothing but this laptop is there at a on-premise. Okay, next, if we have this laptop at somewhere else, example, you are in India, this laptop is there in the US, and you are accessing that particular laptop from India again. Okay, so I will explain it clearly. See, I have my laptop. This laptop I will put it in somewhere else, meaning I'm not going to keep this laptop in my own place. I will keep it somewhere else, but I will access this laptop with another laptop. Now you have to say, first laptop which I don't have at my home, this is there at a cloud. You have to say it is there in a cloud. So cloud means who is going to take care of power supply for this computer, internet for this particular computer, and next you can say cooling system. Okay, better security. Who is going to take care of all these things? Cloud provider is going to take care, because if this server is not at my home, I moved this particular system to US. Let's imagine I moved this server to US now. So in US, where I moved to a Azure cloud data center, Microsoft data center. So when you move the server to that data center, Microsoft team is going to take care of power supply, cooling system, internet, and the security, everything. Now let's imagine another way. If my laptop is there at my own place, who is going to take care of all these things? Cooling system and good internet, power supply, security. I need to take care, because it's my responsibility. This server is there at my place. Okay, understood. That is the difference between cloud and the on-premise. If your server is at on-premise, you need to take care of everything. If your server is at the cloud, everything will be taken care by the cloud provider. If you are putting your server in AWS data center, AWS people will take care. If you are keeping your server in Google data center, those people will take care. Google team is going to take care. Now I am going to keep my uh, server in a Microsoft data center. So Microsoft is going to take care. Now we understood the cloud and on-premise. Now we need to understand what is the why we need to store data in on-premise. Remember, there are some secure data. That data, I don't want to believe anybody, so I cannot store this data somewhere else, right? So that's why all the personal information, example, you look at here, customer information, customer data is very secure. So if you leak any customer information, government in that country will fine you like anything. So there is a huge penalty you need to pay. So that's why these kind of sensitive data, customer information and the customer personal identity, customer phone numbers, all this information we need to store it in our on-premise at our own place, so that we know, so nobody is able to see my data, so my data is secure. So that's why what people will do is, some of the data that is more secure data, they will put it in a on-premise. On-premise means their own place. You see now, to analyze these logs, the company needs to use a reference data such as what is the reference data. So we have collected some logs in the cloud. To analyze those logs, what I'm doing is I need to combine the logs which I received in the cloud plus whatever data I have in on-premise. What data I have in on-premise, you see, reference data such as customer information, all the customers who registered for my game, all their name, all their details I have in my on-premise. Game information, which customer like subscribe to which game, so that information is also available in my own place. Next, marketing campaign information. So in that game, what all features they have enabled. So that entire all these information, see, customer information, game information, and market campaign information that is in an on-premise data store. All this information is available at on-premise. So now we understood customer information, game information, market campaign information is there in a on-premise. Now your logs is available in a cloud. Now if you want to analyze these logs, you need to combine these logs plus this sensitive information, that is customer information, game information, all these things. Now what company is going to do, see, the company wants to utilize this data from the on-premise data store. So whatever data you have in on-premise, the data company wants to utilize. For what purpose they want to utilize? For combining it with additional log data it has in the cloud data store. Meaning whatever data you have in on-premise, that data they want to combining with log data that is there in a cloud data store. So why they are combining these things? To extract insights, to understand which customer is spending more time, which customer is finishing more levels in the game. Okay, to understand all these things, they are going to combine these two data sets, on-premise data set and the cloud logs. Okay, now. So what is the, so how they are going to combine this data? See, it hopes to process the joining data by using a Spark cluster in the cloud. So they are going to use some Spark cluster for joining this data. So in Spark cluster, where they are going to use, they will use something called Azure Databricks for joining this data and analyzing this particular logs. And once it is like, once they use Azure Databricks, what they are going to do is they will do the transformations. After transformation, the data they will publish, meaning they will save this particular transformed data into cloud data warehouse such as Azure Synopsys Analytics. So it's a data warehouse. Since we know what kind of data we will have in data warehouse, reporting data. So once you have analyzed your logs, you will come to know which customer is spending more time for games and which customer is finishing more levels in less time. So all these are the different reports. You will get it from the data. That entire data you will load it into Azure Synopsys Analytics. It's a kind of a database only. We'll have a multiple databases in the backend. Okay, see, formerly known as SQL database. Now, once we have data in this, you are going to use you are going to create the reports on top of it. So by using that Azure Synopsys Analytics data, you are going to create the reports on top of it. Okay, next. So what they wanted to do is they want to automate this entire flow, collecting logs from cloud and bringing data from on-premise, joining this data by using Azure Databricks. This entire process they want to automate. So they want to automate this workflow and monitor and manage it on a daily schedule. So they are going to automate it every day. This particular pipeline will run. So how it will run? We have something called triggers in Azure Data Factory. So you can use those triggers to run your pipeline daily on the configured timing. Next, so you want to monitor and manage it on a daily schedule. So you can monitor whether your pipeline is succeeded or failed. If it is failed, you can configure some kind of alerts to notify you saying that this particular workflow is failed. Okay, next, they also want to execute it when file land in a blob storage container. See here, we automated the workflow based on the timing, maybe daily once. So I don't want to do that. Whenever some new log added into my blob storage, whenever new data, new logs arrived into my system, immediately I want to process those logs. Yes, for that we have a something called event trigger that also you can use to automate this particular workflow. So this is the scenario. Please let me know if anybody have any questions here. Please compare your chat window quickly, friends, at least. There are a lot of people, I cannot call the names. Please respond quickly. So if everybody is good, please ping in chat window saying that you don't have any questions. Yes, sir, no, please ping in chat window, friends. Parmesh is saying good. Thank you, Parmesh. Devendra Reddy is clear. And other people, please respond. Avinash, okay, fine. Okay, I'm just moving on to the next slide. So what is Azure Data Factory? So you see, Data Factory is a cloud-based ETL and data integration service that allows you to create data-driven workflows for orchestrating data movement and transforming data at scale. So Data Factory, it's a service. So this service is whether it is in on-premise or cloud. We just discussed the difference between cloud and on-premise. But this Data Factory is the cloud-based ETL service. It's a cloud. It is available in the cloud. Next, ETL. What is ETL? We are going to deep dive in upcoming slides. But let me tell you, E means extraction. You are going to fetch data from some storage. Next, transformations. So you are going to understand. Example, all the orders information you received into the database. You need to extract that orders information, and on top of that, you need to transform. Transformation means you need to understand. So, what is the total amount you received for laptop sales? What is the total amount you received for selling mobiles? So, something like that, you need to calculate all those things. That is nothing but transformations. Okay, you need to join with your historical data to understand whether your sales is above the threshold or below the threshold. Maybe last time maximum amount which you received is $200. Now you see there is a $250. So there is a growth. So to understand all these things, you extracted the order information. On that you are calculating, you are transforming this data, you are analyzing this data. Okay, so once you transform this data, final output you need to load. L is nothing but a load. Extract, fetch data, then transform data, finally load this data. Okay, ADF is available in the cloud and it is a ETL service. And data integration service. What is data integration? Meaning for fetching data from different storages, it can able to connect. So it can able to connect to the different data storages. That's why it's called a data integration service. Data integration service means Azure Data Factory can connect to the different data storage systems. Maybe databases, data lake storage, blob storage, Cosmos, anything. It can connect to all these different storages to fetch the data. So meaning Data Factory can connect to the different data integration services. Next. So what is the advantage of connecting to these different storages is that it allows you to create data-driven workflows for. So it allows you to create data-driven workflows. Data-driven workflows means whenever you receive a data, you can able to move it to the another storages for processing. Meaning this data-driven. So data movement you can able to do it by using this Azure Data Factory. Once you are able to connect to the data storages from Data Factory, this particular workflow, okay, fetching data, right? So every 5 minutes or every 10 minutes, you can schedule that particular data-driven workflows. Okay, so data-driven workflows we are creating. Next, so once you create these data-driven workflows, so when you are creating these data-driven workflows for orchestrating data movement and transforming data at scale. Orchestrated data movement means you are organizing the data movement. So what data we need to pull from. So next, what data we need to pull next. So because there will be a dependency sometimes. So you need to move the first table you need to copy first, second table you need to copy second. So sometimes what happens, there won't be any dependency. In that case, parallelly you can copy these two tables into the cloud. Okay, so you need to organize. Orchestrating data movement means you are going to organize whether I need to copy these two tables parallelly, whether I need to copy these two tables serially one by one. Okay, once you move the data, you are going to transforming this data at a scale. So it doesn't matter how much data you have. So how much data you have, everything you can able to transform by using Azure Data Factory. Okay, next. So this is the logo for your Azure Data Factory, friends. Next, using ADF, you can create and schedule data-driven workflows. As we just discussed, data-driven workflow. Workflow means what? Step-by-step processing. You are going to say, I want to pull data from on-premise to the cloud. Once I bring the data into cloud, again I need to process it by using Databricks. So then I need to load data into Azure Synapse. So this is the flow you are going to define. Step-by-step processing. First, bring data from on-premise to cloud, transform data within the cloud, then process data, load it into Azure Synapse. These kind of workflows you can create. See, you can create, okay, data-driven workflows, and you can schedule. What is schedule? So this particular process, you don't need to run manually daily. You can tell, okay, every day I want to run at 6 a.m. IST, or I want to run every 5 minutes. Okay, daily every 5 minutes I want to run. So you have a different triggers. By using those triggers, you can schedule these workflows. What these workflows will call? These workflows is called a pipelines in Azure Data Factory. Now, these workflows, what these are going to do, that can ingest data from disparate data storages. Disparate data stores, meaning, so it can bring the data, it can fetch data from different storages, maybe SQL database, file system, REST API, and many more things. So even if I list down all the names, you will not be able to understand those things, because as our sessions goes, you will be able to understand everything. Okay, next. We can build complex ETL process that transform data visually with the data flows, or by using compute services such as Azure HD inside Hadoop, or Azure Databricks and Azure SQL database. Remember here, you were saying you can create a complex ETL process that transform data visually. So if you want to transform data visually without code, then you need to use the data flows. If you want to use a code, okay, if you are going with writing the code, I am good at coding, so I want to go with code, and I have some customized requirement where I cannot, where this particular customized requirement I cannot finish it by using visual data flows. So then you need to go with Azure Databricks, Azure HD Insight, Azure SQL database. So mostly 90% people nowadays going with Azure Databricks. So that's why we will mainly focus on Azure Databricks, but still we will cover Azure HD Insight as well. Okay, next. Can publish or transform data to data store such as Azure Synapse Analytics. As we discussed, once you process your data, once you transform this data, you can load this final data into Azure Synapse Analytics for business intelligence applications to consume. So you have a BI applications to consume this particular data for creating the reports and all those things, as we discussed in our previous scenario, right? So exactly for that scenario, you can use the Azure Data Factory, because you can able to define workflows. You can just organize that particular data movements, and you can schedule those data movements. Okay, so this is the basic about your Azure Data Factory. Okay, any doubts in this particular slide? Any doubt? Please respond quickly, friends, because we don't have much time. Even yesterday we have missed some slides. Right? Okay, fine. Let me move on to the next slide. So what extract? So what is ETL? T means transform, L means load. Okay, so you are going to extract data from maybe SQL Server, maybe file system. You get the data from REST API. So it depends. So based on your client, maybe they have data in SAP systems. They may have data in like any other like mostly people will use nowadays. What is that? People mostly will use SQL Server, otherwise file system, REST API, and there are 80 plus connectors, meaning Azure Data Factory can connect to the 80 plus services. So you can connect to all of these different services. So you can able to extract the data. Once you extract the data, you are going to transform this data by using services called Databricks or Azure HD Insight. So once you transform this data by using these services, you can load this data into Azure Synapse Analytics. This is the ETL processing. You extract data from these stores and transform this data by using these compute services. Once you transform this data, load final data, you are reporting data into Azure Synapse Analytics. From here, we will have a BI applications which will connect and create these reports. Okay. So any questions here? Okay, fine. Next. So ETL overview. So ETL, so what is ETL? You will try to understand. ETL is used in data warehouse. Users needs to fetch the historical data as well as current data for developing the data warehouse. Okay, the data warehouse data is nothing but combination of historical data as well as transactional data. So as we discussed yesterday example, let's consider who is the best cricketer. I want to understand. How you are going to understand? You need to take care of current data and you need to take the historical data. You need to join these data to understand who is the best cricketer. So this is the easy and simplest example that I can give you. Okay, so I want to understand who is the best, like you can say, best digital transformation company. So you need to look at the company who has delivered most of the projects in less time and who is delivering the machine learning projects and which company. So you are going to identify all these things to understand the who is the good, which is the good company in digital transformation, something like that. Okay. Okay, so that is the kind of a, so what happens is when you take the historical data and current data, so you can able to understand who is the best cricketer, right? So this is kind of a reporting. So you can report it. Okay, is the best cricketer. When you are able to report it, so when you take current data and historical data. Next, code free ETL as a service. So these are the main things that you need to know. In Azure Data Factory can ingest the data, meaning it can fetch data from different storages and load it into the cloud. And when you are loading the data, you can control that particular flow. Okay, let me just go one by one. Ingest. So you can connect to the different storages and you can connect. See here, multi-cloud and on-premise hybrid copy data. So you can copy data within the cloud or you can copy data from on-premise to the cloud. Next, you have a 90 plus native connectors, meaning 90 different data stores you can able to connect. Okay, next, serverless and auto scale. So you don't need to worry about this particular servers and all those things. It will taken care of automatically. Okay, suppose you want to quickly copy some data, you have something called templates. That is nothing but a user widgets for quick copy jobs. So if you want to quickly copy the data, then you can go with widget. That is nothing but a templates. So that's how you're going to connect to the 90 plus native connectors to pull the data into the cloud. So once you are pulling the data, how you are going to pull this data is you will have some control flow. You can tell. So if the table is starting with the cloud pandit, name is starting with cloud pandit, then only I want to do. So such kind of controls you can put. Okay, and you can also design two branches. Two branches means so two flows you can define. Okay, so at one flow side, at the top flow, you are copying data in this table. In below flow, you are going to copy data science tables. Okay, data science team will have separate tables. So those tables you are going to load. Something like that, you can maintain a two different branches. See, design code-free data pipeline. You don't need to write any code in Azure Data Factory. Everything is a visual, friends. You just drag and drop. So very easy. Next, you can generate these pipelines by using UI, but if you're interested to use coding, example Python, .NET or PowerShell, by using those things also you can create the pipelines. Next, utilize workflow constructs, loops you can use. Okay, I want to I want to copy table one by one, then you can use loops. Branches, as I said, for two kind of flows, if you want to define, you can define another branch. Conditional execution. I'm going to put some conditions. The table name is starting with cloud pandit, then only I want to move. Something like that. Okay, variables and parameters you can use for storing some variables. Okay, next. By using these two, just you are ingesting data. But now by using data flows, you can able to transform the data. See, data flows is like code free. You are not writing any code, it's a visual. Code free data transformations that execute in Spark. Okay, so this code free data transformations which are created those will execute on the Spark cluster. This Spark cluster you don't need to create, automatically it will create in backend. Next, scale out with Azure integration runtime. Meaning by using we have a something called integration runtime. It's nothing but a compute power. By using those things, you can increase those integration runtime to get the better performance. Scale out. Okay. Next, generate data flows via SDK. So just now we have seen right here also. Not only UI, you can use some Python, .NET, or PowerShell for creating the data flows. Next, designers for data. So this is designed for data engineers and data analysts. So for data engineers and data analysts, they no need to write the code. They simply go and do it everything from the UI. It's a code free. Next, so whatever data ingested, whatever I'm transforming, these things I want to schedule it. I don't want to run every day morning 6 a.m. I will wake up and I will run my pipeline. No, I want to say, hey, pipeline, please run every day at 6 a.m. For that, we need to schedule it. So we have a something called triggers in Azure Data Factory. There are three types of triggers. One is schedule trigger, second one is tumbling window trigger, third one is event trigger. So by using those things, you can able to schedule your pipeline. Okay, build and maintain operational schedules for your data. So for your data, you are going to schedule these things. Next, so it's based on a wall clock, meaning schedule, fixed time. Event based, whenever some event occurred, maybe some file arrived into storages, immediately that file I need to pick based on the tumbling window. So based on fixed size of window, I want to process historical data, then you can use the tumbling window. I know it is not, you cannot able to understand everything now, but as we discuss with practicals, you'll come to know how exactly we are using this schedule window and the event based trigger, tumbling window, all those things. Okay. Next, but ultimately you have a triggers which will automate your pipelines. Next, monitor. So you can monitor your pipelines. Previously ran pipelines, you can able to check it, and currently running pipelines, you can able to check it. And if some pipeline failed, you can create some alerts which will send the notification. You see, view active execution and pipeline history. So pipeline history you can see, the active jobs, active pipelines also you can see. Detail activity and data flow execution you can able to see. Finally, establish alerts and notification. So you can create a alerts to send a notification whenever some pipeline failed. Okay, clear? Any doubts in this? Uh, Please respond, friends, because I'm just thinking. If you have any question, let me know. Maybe Krishna Chaitanya. Okay, so if you respond quickly, I can able to proceed further. Okay. So Bharat, Krishna Chaitanya, everybody is clear. Thank you all. Now, now let me go to the next one. Okay, why Azure Data Factory? See, this is the Azure Data Factory logo, as we know. Big data requires service that can organize, orchestrate, and operationalize process to refine these enormous stores of raw data into actionable business insights. Meaning, whatever logs you have received, those logs you need to convert into a understandable format. Because logs means, okay, this guy started playing this game and this level is finished in this time. So some logs will come. There is no there is no point in viewing those logs, right? You need to extract the whatever information you need from the logs, and you need to create the reports. So meaning you have a lot of raw data. That is, logs is nothing but raw data. That raw data you need to convert. You need to operationalize this process to convert this raw data into a understandable format. That is nothing but a refine. You need to convert the raw data into refine. Okay, so for that we need a one service. That service we are going to use as a Azure Data Factory. Okay, because we just discussed, right? So Azure Data Factory, you can define the workflows, you can schedule the workflows, you can monitor these workflows. You have a different things, right? For transformations, for ingesting data. So for all these things, it's a completely code free. You don't need to write any coding. So if you get other services, you need to write the coding. So what happens is, in real time, in production, right? In production, something failed, they will allow you to fix it, those issues, in 1 or 2 hours. So if you are writing code, it will be difficult for you to understand where exactly in code it is failed. But if you think about your UI, so you know exactly this particular activity got failed. So you will go into that particular activity and you will look into it why it has failed. It will be easy for you to debug as well. So if you're doing something through UI. But Azure Data Factory is not restricted to code free, but you have some code which you have written in Azure Data Factory. That code also Azure Data Factory can execute. Azure Data Factory can execute your code also it can execute. Okay, don't think that it's completely code free, you cannot execute code. You still can execute your code, okay, from Azure Data Factory. You can connect to the, you can integrate ADF with the Databricks or ADF with Azure HD inside ADF with machine learning, so everything. Okay, next, Azure Data Factory is a managed cloud service. It's a managed by cloud people. It's a managed cloud service because it's managed by the cloud people. That's built for complex hybrid extra transform load and extra load transform. So if you look at here, ETL and ETL, and this is also ETL, a small mistake here. Let me correct. This is a ELT. This is ELT, not a ETL. I don't know why this mistake. Okay. Now you see Azure Data Factory is managed cloud service that builds for complex hybrid extra transform load and extra load transform. You see, it's a ETL. Take the data, transform it, and load it. So not only ADF will support ETL, it also supports ELT, meaning extract, load data into cloud first. Transformation you can apply whenever you want to apply, maybe